Okay, so today we are looking at a different or another method for solving a differential equation. That's the first order differential equation with a constant coefficient. So this method is called the D operator method. So we are first looking at using the D operator method for the first order differential equation with constant coefficient. So always this is the form for a first order differential equation with constant coefficient. So it is a linear form. It is a linear form. dy dx minus a constant ay equals to r of x. So this we can clearly see that this is a first order linear differential equation. But here is with a constant coefficient. Okay, so the D method or the D operator method is applied here. So we should first notice this. These are basic concepts we should know. So dy dx is the same thing as y prime, and it can be written as d. So anytime you see a d, it means the first derivative, that's y prime. They are all meaning the same. So that's the first order. And anytime you see the square y, the x square is the same thing as y prime prime or d square. So it is a second order. Same apply to the cube. So generally the dy dx minus ay equals r of x. That's the form for first order differential equation with constant coefficient. Remember, it is linear. Here it is linear. So in the D operator method, we always make a substitution for the D. Okay, so that's why I first wrote this. So looking at dy dx is the same thing as my D. That's the first order. So I can make a substitution here. So I'm going to get my D, that's the dy dx, minus a factorizing my y out. So remember, this is dy dx, and this is minus ay. So it's d dx of a certain variable, and that variable is y. So the d, that is the operator d, minus the constant a, is operating on a certain variable y. That is the dependent variable, and that's operating, or that's this y, that the dependent variable of which the d minus a is operating on, should be equal to my r of x. So my y, I can make my y the subject after applying my D operator method. So from here, I'll make my y the subject. I'm going to get 1 over D minus A operating on R of x. So further on, we know that from the general equation dy ds, that was the y prime minus ay equals r of x. That's the linear first order differential equation with constant coefficient. The idea is that we have a linear function, we try to find the integral factor. Remember, we've done that previously. So we are using that idea for the D operator. So we will find my integral factor. So I am proving how we came about by the D operator method or the D operator formula. So I know that my P of x, by comparing to the first order linear differential equation, my P of x is minus a, and my y prime is here, and this by Q of x. By here we represented it as r of x. So my P of x, which is equal to minus a, I can try to further on find my mu, that's the integral factor, So the integral factor becomes the e exponent integral of the p of x. But my p of x is my minus a. So integral of minus a dx. But my a is constant, so my minus a can come out. So I will integrate with respect to dx. Then when you integrate with respect to dx, you are going to get x. Anytime you integrate dx or a derivative, you are going to get x. So you are going to get e exponent, this constant minus ax. So this is your integral factor. Then from our knowledge in first order linear differential equation, after finding your mu, that's the integral factor, you try to multiply through by the general expression. This is the general expression. So we try to multiply through by the integral factor. So multiplying through, we had e exponent minus ax, then we multiply through by this, the general form of first order with constant coefficients. Remember, it's linear. So when you multiply through the whole of this equation by the integral factor. So upon doing that, you know that my e exponent minus ax will multiply by y prime, then this will multiply this. You are going to get e exponent minus ax. You use this one to multiply rx, so you are getting this. Then we can more or less say that by left hand side is a sum product. It was y multiplying e exponent minus ax. So I can clearly see that when I keep my y constant, that's my y constant, and I differentiate e exponent minus as, I am going to get minus a e exponent minus ax. And also, when I keep e exponent minus ax constant, this is my e exponent minus ax, and I differentiate y, because it is a function of x, so I'm going to get e exponent minus ax, then we attach dy dx to this, that's the y prime. So from this place, I can say the whole of this one can be written as y multiplying y exponent minus ax. So my y prime, my e exponent minus ax y prime minus ae exponent e exponent minus ax. It is a sum function, and it is dx of this function. And now I have further simplified it as y exponent minus ax. So I'll try to integrate both sides. So upon integrating both sides, we are going to get the integral factor is going to take off the dx of the y minus ax, then you are going to get the right hand side to be integral of e exponent minus ax r of x dx. Okay, so now the left hand side is going to let with by y e exponent minus ax, then the right hand side to be going to get integral of e exponent minus ax r of x. So here I'm trying to make my y the subject, so I'll divide through by e exponent minus ax. So I'm going to get 1 over e exponent minus ax after dividing through, multiply by e exponent minus ax r of x. Then this e exponent minus as, when it goes to the top, it becomes positive, so it will become e exponent ax multiply integral of e exponent minus ax r of x. But my y from here we saw, so from here we saw my y to be 1 over the d minus a. That's when we apply the d operator on the general form for first order linear differential equation with constant coefficient. So that y is equal to 1 over d minus a from the previous slice is here. Then because this y is equated to 1 over d minus a r of x, And the y2 is also giving us e exponent ax, integral of e exponent minus ax. We can equate the two. So my 1 minus d minus a r of x will be equal to e exponent ax, integral of e exponent minus ax, r of x. So this is the general formula for the D operator method. So anytime they give you a question on the D operator method, you try to apply the operation D on that particular equation. Then after that, whatever value here, we will write it here. So that will become the exponent. But remember, the one outside the integral will become positive, and the one inside the integral will become negative. Okay, so some examples will follow. So this is how we got to know our D operator. Thank you very much.